Hi guys, in today's video, I'm going to be discussing the second fundamental theorem of calculus. I'm going to be continuing with the AP Calculus BC syllabus. So the second fundamental theorem of calculus states that d by dx of integral a to x f of t dt is equal to f of x. So we know that d by dx is the differentiation and integral is nothing but the anti-differentiation. So these two get cancelled out essentially. And then when you have a constant, so it's important to remember that a is a constant and x is just any value of x. So let me give you an example of this. So d by dx of integral 1 to x t square dt would be equal to x squared. So we just plug in x for t. So I can expand this and show you how we come up to x squared. So we would get d by dx of t cubed by 3, 1 to x. This would be d by dx of x cubed by 3 minus 1 over 3. And we know that the derivative of a constant is 0, and the derivative of x cubed by 3 is 3x squared over 3, which is x squared. Thus, we have proved this theorem. And now another important thing to remember is when you have d by dx, but in this case, x is the lower bound and the constant is the upper bound. Using our rule of integrals, this would be negative f of x. And this is the case when the constant is the upper bound. So now we have seen what happens when it's just x. Now let's see what happens when you have a function instead of x. So d by dx of the integral a to g of x. So g of x is a function. F of t dt is equal to f of g of x. So we plug in g of x into the function f of t into the derivative of g of x, so g prime of x. So this is just through chain rule. So now let's look at an example of this. D by dx, d by dx of integral -1 to x cubed. So x cubed is the upper bound and it is a function. And the function is 1 over 1 plus t dt. So this would be, so we plug in the function for t, so 1 over 1 plus x cubed into the derivative of the function. So the derivative of x cubed, which is 3x squared. So this would be 3x squared over 1 plus x cubed. Similarly, let's look at another problem. D over dx of 2 to sine x. So these are the bounds. Cube root of 1 plus t squared dt. This is equal to cube root of 1 plus. So instead of t, we plug in sine x. So sine squared x. But we're not done as we have to differentiate the function, which is sine x. So into cosine x. So this is what we get. So this is the second fundamental theorem of calculus. That's it for today's video, and I hope you enjoyed. Thank you.